Hello, so this video covers the atomic spectroscopy section of the inorganic chemistry notes. So when energy is transferred to atoms, the electrons within these atoms can be promoted to higher energy levels. To allow the electrons to return back to their original levels, you have to lose that energy from the atom. Now that energy is released in the form of a photon. When an atom emits a photon of light energy, that happens when an electron moves from a higher energy level to a lower energy level. So an atom will emit a photon of energy when an excited electron moves from a higher energy level to a lower energy level. The light energy that's emitted by an atom produces a spectrum that's made up of a series of lines of discrete energy levels, quantized. And this provides evidence for the existence of these energy levels. So in summary, when an electron absorbs energy and is promoted to a higher energy level, that's the absorption of energy, of a light of a specific wavelength. And when that excited electron falls back down to a lower energy level, then energy is emitted. So we have absorption and emission spectroscopy. So each element has its own characteristic atomic absorption and emission spectra, and these can be used to not only identify the element, but also to quantify it, so as how much of it is there. In atomic spectroscopy, that's emission and absorption. The concentration of an element is related to the intensity of the light either emitted or absorbed. So as your concentration increases, the intensity of light, either emitted or absorbed, will increase. Let's have a look at atomic absorption spectroscopy. So in absorption spectroscopy, electromagnetic radiation is directed at a sample. So here we've got a white light source being directed just at a prism. You've probably seen this experiment early on, maybe in first or second year, and you disperse white light into its component parts. In atomic absorption spectroscopy, the radiation is fired at the sample. It's then passed through a prism, and you will see that parts of the continuous spectrum have been absorbed, and they're represented by lines. So radiation is absorbed because electrons within that sample have been absorbing specific wavelengths of light. So an absorption spectrum measures how the intensity of absorbed light varies with wavelength. Emission spectroscopy is slightly different. In emission spectroscopy, the sample is excited first of all, So you heat the sample, for example, in a high temperature, like a flame, and this excites the electrons, So you use that first of all. So you already have promoted the electrons to higher energy levels. And then what you are measuring is the energy or the light that is emitted when the electrons drop to lower energy levels. So in an emission spectrum, you're measuring the intensity of light emitted at different wavelengths. On the next page, you can see some example spectra, and you can see how they are specific to specific elements. No two spectra are the same. You will need these spectra to be able to answer some of the questions. What I would suggest that you do is you watch the atomic and emission spectra video, because that shows exactly what's happening in the atom and how these lines are generated. And then you should answer questions 6 to 14 on your inorganic chemistry questions section. There's also a short check test to do as well. Please ask if you have any questions.